All right, good day everybody. Today we're going to be doing Conservation of Energy Lab. What we're going to do is have this cart move because gravity is pulling this down. So as this hanger drops, it will lose potential energy and transfer it into kinetic energy of the whole system. So we're going to see the cart and the hanger speed up because we're losing potential energy here and gaining kinetic energy in the whole system. So we're going to watch that happen with the motion sensor at the end that you've used before. The computer is going to take all the data and plot us a nice position versus time graph. From the position versus time graph, we should be able to get some information about the height, because if this moves 10 centimeters, then this moves 10 centimeters. So we can get MGH, the potential energy that this loses, and then we can get from the graph some information about the velocity, so we can calculate 1/2 mv squared for the whole thing. The whole m is moving here, right? So we're going to get 1/2 mv squared, and we're just going to check the amount of energy that this loses in potential. Do we gain that same amount in kinetic energy for the whole system? We should be pretty close. There is a bit of friction and some losses to thermal energy here, but overall we should get very, very close. So the setup here is what we've used before. We're going to try to make sure, obviously, that the track is level, your string is level, make sure there's no dirt and stuff on the track, stuff that's in the way of the wheels. If you hear the wheels being really scrapey loud, then obviously there's something wrong with your wheels. You can try to get another cart so that we can try to get it pretty friction free.
Keep going.
All right, now let's go in and level the track. So we obviously want to get this thing level. If we're going to zoom in on our level, we'll put the level on the track. It looks pretty good there. You can adjust it down a little bit, maybe here and so on. And I also want you guys to level the track across like that as well, to make sure that the track isn't like this. That kind of interferes with how well the cart can travel down the track. And also have a look at the string. Make sure there's nothing interfering with the string. Make sure that wheel can spin nice and easily, right? Friction free. And try to get the string level as well. So you can adjust it down or up here. And that's a little harder to do because you can't really stick the level on it, but you can kind of eyeball it pretty good and make sure we're not pulling the cart up or down. We're pulling it horizontally. So we're all set up now, ready to go. The instructions say, obviously, that we're going to have a 500-gram mass on the cart, and then we're going to have 3 100-gram masses standing by to do different trials where we add some mass into the system. So we're going to have a partner here. We're going to start. I don't know if you guys can see the graph. From that, we'll have a close-up of the graph later on. But the start button, you can hear the motion sensor going, and then we'll just let that go. And we should see, we've got it set up so that you guys can see if we're accelerating here. We should see a quadratic graph. And sure enough, here on our graph, you can see nice curvy graph going like this. We've got it set up so that it kind of measures from the floor up kind of thing. So on this graph, we're going to try to get our information about H. How high was this? How much did it change its height? So we can get MGH. And then we're going to measure something about speed. How fast was it going over there and over here, so that we can figure out how much the velocity changed, and we can figure out how much mv squared over 2 has changed.
Wrap up.
Okay, we'll do the analysis of the graph momentarily.
Wait, I'm gonna keep recording.
Okay.
This way it's gonna make it easier to edit in YouTube.
Okay.
And now we're gonna show some close-ups. Do you want to back it up to the start here?
Okay.
The whole experiment?
So you'd like do this
we're gonna come back and we're gonna show the close-up of the level on here.
Okay.
So I'm still recording, so we're not gonna have any sound here, but while you're talking, we're gonna cut to this shot, so you can show the level,
Okay.
and we can see that
So you take a snippet of this and move it over.
we're gonna move it over there, and now we're gonna show the level going the other way, perpendicular to where it was, yeah. And we also adjusted the wheel over here, let's show that. Oh, and what you should do is this too. I'm tapping on the screen so we make sure that's in focus, and that the camera is exposing for that. All right, and now you can move it up and down how you did before. Anything else you want to get a close-up of? We'll get a close-up of the screen in a second, we'll run it again. But anything else on here? You want to show?
Don't think so.
I guess we should. We didn't say it, but.
Okay, well, he talked about it. So we'll just show that. Do you want to? Okay. Do you want to talk right now and whatever you want to say about it?
We can, like, the students have used these before, so I guess we should always say it, but, yeah, obviously, as always, we'll keep the motion sensor pointing directly down the track. So this part here should be perfectly vertical, and just double check that the button on top is set to cart rather than person.
Do you want to reset this? And then we'll run it again. We can actually just show the screen. But having said that, you'll probably get what's called, well, it doesn't record screens very well. We have to do a screenshot of it. We'll see. We'll just see how it goes here.
Because the refresh rate is different.
That is correct.
I'm just saying, Paul, but next time maybe we should actually have it here, this screen is big enough, big screen.
There we go. That's a good idea. Do you want to reset it to back to 0? Or I don't know how to do it. But.
Yeah, sure.
All right, if you run it again, and then what you come back, you were pointing at whatever the graph. Do that. Just do that again. Just going to see what it looks like on here.
Okay.
So when you are pointing, just stay out of the. Just use your finger. So run it again, and we'll see the graph run. Right?
Okay.
Correct.
Ready?
Yeah, it's still recording.
Okay. So we'll hit record, and you can hear the motion sensor going, and then we'll just let it go. And we should see a nice quadratic graph because it's accelerating. And certainly right there, if you want to zoom in a little bit, have a look at it. It looks pretty quadratic to me. We've set it up so that the graph is measured kind of from the floor up, so you can see that part is nice and quadratic along through there.